Hello, this is a very short video to show something that I didn't expect and I found remarkable to show. I was planning on using a reed switch in an upcoming small project to detect rotational motion. So a reed switch is a small glass tube that you can see here. It has two contacts inside that are almost touching each other but not quite. If you move a magnet around this switch, the contacts will come together and current can conduct through the device. I was looking in a datasheet how to orient this thing with respect to a magnet. So I was expecting that it had to be used in one specific orientation and it wouldn't work or would work very badly if you oriented it differently. I mean, if you rotated it around its own axis with respect to the magnet. However, datasheet didn't show that. Then I checked another datasheet for a similar device, also didn't show that. So I thought, why is that not relevant? How does this work? I can show that it works differently than I thought using this box. This is a small box that can show the state of a signal using this LED. Let's use the first LED. Now I'm going to use a like long magnet with north and south pole on the end, right? So that's it. I'm going to show that it works. You can assume that there's no magnetic fields coming out of this box, not relevant ones, because I tested it on a bench and it doesn't make a difference. So I'm going to use this plastic ridge to keep a constant distance between the magnet and the switch, right? And I'm going to slide it in front of the switch. What you can see is that I move it a little bit closer. If you slide it in front of the switch, a little bit closer still, the LED will go on once, right? If it gets near the switch, the magnet gets near the switch, the LED goes on. However, if you move the magnet closer to the switch, so now I have approximately 2 millimeters between the reed switch and the magnet, you will see that it goes on, then it goes off, then it goes on again, then it goes off, then it goes on again. So now I'm moving the magnet with a constant distance from between the magnet and the reed switch, or the reed switch leads. And move it from left to right. It goes on, off, on, off, on. We'll move it further away. It goes on, off. So you have either 1 or 3 switch moments when you move the magnet in this direction along the switch. Now that is because I read on the brilliant internet if you have a reed switch like that. What I thought how it worked was that one of these contacts was thick or static or stiff and one wasn't. So if it was oriented correctly towards a magnet, then if your magnet pulls one contact towards the other, to the flexible contact towards the non-flexible one, then it would make contact and current could conduct. However, that's not how it works. If you have a magnet like we just had, let's assume it has a north pole there and a south pole there, and we move it left and right with a constant distance d towards the axis of the switch, and you move it along this line. When it passes through lobes, let's say that lobes are shaped like that and that, something like that, looks a little bit like an antenna lobe, something like that. So if you pass the magnet through these lobes, the switch will go on, the switch will turn on. So if you see that if you make the distance big enough that it only passes through the topmost lobe, then you only get 1 switch moment. However, if you pass the magnet closer by the switch, then it passes through 3 lobes and you get 3 switch moments. And I found that a little bit remarkable, so maybe not for you, but it was for me. So enjoy and have a nice day. Goodbye.